Raise your hand if you know the answer.
Letters, letters.
Yes, you're correct. These are letters, but they make a word.
How?
Let me show you this. Do you want me to run or run with these?
Yes.
R-U-N.
Run. So what you're saying is, I have letters, and if I mix them together, they
Like
make
my name. I have an A, a R, Y, and those are all letters. A, R, Y, A, V, E, V, A, L, L, E.
Okay.
Arya Valley.
Got it. So letters make up words. What does that have to do with that?
Well, that was just an example. When you make words, sorry, it's the same way how you make elements.
How?
By combining the neutrons, electrons, and protons with the red one and the lines. When you're making potions inside the shower, you're putting these inside. They're so tiny, you can't even see them through your eyeballs.
Oh, wow. So you're saying that the chemicals I use are all different elements?
Yes,
Wow.
even mercury, including your shirt,
Wow.
including my stick, including everything actually. Everything you touch is
Atoms.
atoms.
Wow. Can you give me an example of something, like how you mix different protons, electrons, and neutrons to make something?
See these things on these atoms
Yes.
on your table?
Yes.
Can you try to guess which one before you flip it over? So you know which one it is? Just to make sure.
Well, I haven't gotten to this part of the book yet, so I don't know.
Well, flip them over so you can.
Oh.
So what it means, it takes a protons, a neutrons, a electrons, and it equals oxygen.
Oh. So the amount of atoms and
Are
electrons-
inside, then they equal the amount outside, and then they make carbon or whatever, or helium or hydrogen.
Oh, so that's why you explain how letters make words and different amounts of atoms, electrons, and
Like including this.
neutrons.
This is 6. And it equals carbon.
Oh, okay.
So I added 6 to the board because I thought it was about. I shouldn't have thought about A, but. So students, these are 180 18 elements, and they're all different kind of ones. Like 1, which is this one, which is hydrogen. 2, we don't have 2. 2 is, where's 2? 2 is helium, right here. Oxygen will be, since it's number 6, then it will be a number 6.
I think it's the pink ones.
Yes, the pink ones. 6 is carbon, and then 8 it is oxygen. And it all says all of them in this periodic table. It'll take you a long time.
Wow.
And there's numbers so you know what they are. And there's like letters so you know what they start with. Do you want to say something?
Yes.
Do you have to go to the bathroom again?
No.
Okay, good.
But I forgot one more thing. So, you know how I told you about Democritus?
Yes.
You know, he always thought that there was nothing smaller than an atom. But recently, we have figured out that there are things smaller than an atom, and they're called quarks. And it got me thinking, like Democritus, I wonder if there's something smaller than quarks, and something smaller than the thing that's smaller than the quarks. And I wonder if the people in the future are going to figure this one out.
Well, they're a little too hard, so we don't really know. If Democritus was alive, then he will know, but he's already dead.
Right, and he said, that's it, the atom was the last thing. And then we figured out that, no, there's the quarks, which are smaller than an atom. So maybe our future generations will figure out what's smaller than a quark.
Did you know a robot splitted atom and then they found out there's quarks smaller than the atoms?
Yes, it was a Hadron Collider.
That's how they figured out that's the smallest thing they're ever going to see ever again.
It takes about 17 miles of magnets crashed into each other in order to be able to split the atom. And that was interesting. So I wonder what they'll have to do in order to figure out what's smaller than a quark.
They're maybe going to have to split the quark.
Oops. Now that will be something we will love to learn, right?
You are correct. You're correct. Thanks for watching. Bye.